Hi guys, today we're going to review fractions. We're continuing our theme of number appreciation, and we're dealing with the type of number that a lot of people, including the natural numbers in our video, really hate. And those are called rational numbers, or fractions. And a fraction, or rational number, is any number that can be expressed in the form of a ratio. So a ratio is something like this, 1 over 2. That's 1/2. Or it could be 3 over 2, which was one of the characters in the video, I think, and he showed up once as 4 over 6. Other rational numbers are 171 over 100. It can be any two whole numbers from negative infinity to positive infinity that are divided into each other. So, first we're going to talk about the multiplication of fractions. When I have two fractions that I want to multiply together, let's say I have 32 fifths and 2 sevenths. To multiply fractions together, it's super easy. All we do is multiply the numerator times the numerator. That's the top number times the top number. And that becomes our new numerator. So this would be 32 times 2, gives me 64. And then to get our new denominator, which is the bottom, we multiply the denominator times the denominator. So that would give me 35 on the bottom. So 32 fifths times 2 sevenths would equal 64 35ths. So that's how the multiplication of fractions works. That's an example. To write this out in a general way, I could say that for any whole numbers a, b, c, and d, if I had the two rational numbers a over b times c over d, the result of the multiplication would be ac over b times d. So that's how multiplication of fractions works. Really straightforward. The next thing that I want to talk about is the addition of fractions. So when we want to add two fractions together, there's one really straightforward scenario, and that's when we have the same denominator. So for instance, if I have 2/3 plus 5/3, and I want to add those together, when the denominator is the same, all we have to do is add the numerators and keep the original denominator. So that would give me 7 over 3. All I did was add 2 plus 5 on top, and that gave me 7 over 3. Now it gets more complicated when we have different denominators. So let's try 1/3 plus 1/4. What we're looking for in this case is we're looking for what's called the least common multiple. And that's the lowest number that both 3 and 4 can multiply to give us. And it turns out that often it's going to be the case that to get the least common multiple, we'll just multiply the denominators together. And that would give us the least common multiple. So both 3 and 4 go into 12. So if we want these to have a common denominator, we want them to have the same denominator, we would need to multiply each of them to get the denominator to 12. And the way that we're allowed to do that is using the fact that in algebra, we're always allowed to multiply a number by 1, and we'll still have the same equation. So another version of 1, as we explored in the Weird Numbers video, is I'll write some versions of 1. 1 is equal to 3 over 3. It's also equal to 2 over 2. It's equal to 100 over 100. It's also equal to 4 over 4. So I can use any of these versions of 1 to multiply using the rules of fraction multiplication to get a common denominator here. So what I'm going to want to do is take 1/3 and multiply it by 4 over 4. And then I'm going to add that to 1/4 and multiply that by 3 over 3. And doing the multiplication that we just reviewed, we know that I'm going to multiply the numerators together to get my new numerator and the denominators together to get my new denominator. So 1 times 4 is 4. 3 times 4 is 12. We've got the 12 that we wanted in the denominator. And I'm going to add that to 1 times 3, gives me 3, and 4 times 3 gives me 12. So now I have two different versions. I have a new version of 1/3 plus 1/4, but with a common denominator of 12, so I can add these together. And that gives me 7 over 12. Okay, if this pace feels slow for you, we're about to move on to exponents and things will get more exciting. Before I go there, I just want to point out that subtraction works the same way. We still need a common denominator, and once we have a common denominator with the fractions, we can subtract the numerators and retain the denominator, just like normal. So, moving on to exponents. Oh, sorry, I have one more thing to cover. Division. So, we'll often see the division of two fractions, and it's kind of a weird concept to wrap your head around, but the way that it would work, if I have 2/5 and I'm dividing by 2/3, anytime you have a fraction divided by another fraction, it's the same as taking the first fraction in the numerator, 2/5, and multiplying it by the reciprocal of the denominator. So we just need to take the denominator, we need to take the fraction that we're dividing by and flip it over and multiply instead. So I'll have 2/5 times 3/2. And that's going to give me 2 times 3 over 5 times 2. You might notice that these 2's cancel. We'll have 2 divided by 2, which will give us 1, and we'll end up with 3 over 5 as our answer. Okay, so that's how division works. So the last thing I want to talk about is exponents. So when we're working with fractions and we have exponents, it's a lot like when we have normal numbers with exponents. So here's an example. If we have 2/3 squared, you might remember that exponents distribute across multiplication. That's what we've been talking about the last couple of days, how we can use the distributive property. Exponents also distribute across division. So when I have 2/3 squared, like this, I can take that exponent and distribute it to the 2 and the 3. So I'll end up with 2 squared over 3 squared. And that gives me 4 over 9. And just to point out, this way of doing it, distributing that 2, it works out the same as what the exponent means by its definition, which is to multiply whatever number this is. When we're squaring something, we do the number times itself. So that would be 2 over 3 times 2 over 3, which is going to give me 2 squared over 3 squared if we follow the rules of multiplication. So I'll have 4 over 9 if I approach it that way too. Okay? So exponents with fractions, they really work the same way that exponents work with whole numbers. The last thing that I want to talk about is negative exponents. And so if I have 2/3 to the negative 2, a negative exponent means that we take the reciprocal of whatever the exponent is being applied to. So the first step to solve 2/3 to the negative 2 would be to get rid of the negative sign in the exponent. So I could rewrite this as 3/2 squared. And I could keep going with the problem from there. So then I would have 3/2 times 3/2 by the definition of an exponent, and that would give me 9 over 4, which is the reciprocal of the last problem that we did. So any number a over b, any fraction a over b to the negative 1 power equals b over a. And because this is the relationship, something raised to the negative 1 power is often called the inverse or the reciprocal. So some important numbers that will come up in your activity, we're going to do an activity using 1/2. So what would 1/2 to the negative 1 be? I'll give you a second to think about that. 1/2 to the negative 1 is just going to be the reciprocal of 1/2, which is 2 over 1. 2 divided by 1 is just 2. Okay? Now, 1/2 to the negative 2, let's get rid of the negative sign first. So that'll be equal to 2 over 1 squared, which is really just equal to 2 squared. And 2 squared is 4. And it's going to continue following this pattern because when we raise 1/2 to the negative 1 power, that just turns it into a 2. So when I do 1/2, the last one, to the negative 3 power, that's going to be the same as 2 cubed. And 2 cubed is 2 times 2 times 2, which is equal to 4 times 2, which is equal to 8. So 1/2 to the negative 3 is the same as 2 cubed. So these will come in handy for your activity. Good luck practicing your fractions, and have a wonderful weekend. I will look forward to seeing you on Tuesday. Bye!